not come with slides, but with kind of a vision. Sorry? It's switched on. You don't.
It is that. It is just take it close.
Should we change microphones? Yeah?
Yes. So take it close. That's the only difference.
That one's better. Yeah.
Just
okay.
like.
Okay. Yeah, we'll discuss that later, Reinhard. Yeah. Okay. So the vision is somehow inspired by a visual experience I had. I was in my time as a member of the Senate Committee of the German Science Foundation for Collaborative Research Centers, where I had to visit Sonderforschungsbereiche, collaborative research centers of all kinds. And at one opportunity I was in Munich, and that was a virologist SFP. And in virology, as probably many of you know, you look into using viruses for gene therapy. Yeah? So that means you insert a piece of good DNA to a virus, and that is then transported by the virus and propagated through the cells of a human body, of a person who has a genetic disease, and bad DNA is replaced by good DNA. And in one of the projects, they looked into the precise process of propagation. And the conventional way of doing this is they take a large set of cellular tissue and inject the viruses, and then at a certain point, kind of a snapshot. Don't ask me how that works. Yeah? So they look where the viruses have gone, and then they take a lot of samples, and then can compute statistical values about the distribution of the genetic material through time. Yeah? So that's the conventional method. And in this project in Munich, that was one of my the most impressive demonstrations I ever saw. They had done the following. First of all, they had inserted into the virus a piece of DNA that made the virus emitting light. And then they had a special new kind of a microscope. So that was the main point about the project. And don't ask me about details. I have forgotten everything. But I didn't forget one thing. You could observe the itinerary, the trajectory of the virus moving through the cell, driven forward by Brown molecular motion, and then going through the cell membrane from one cell to the other, and then entering a nucleus, and so on. And that was very, very impressive. So that was a very impressive demonstration. And now you ask what that has to do with language technology. Now, in language technology, we have been very successful during the last 2 decades, let's say, with statistical methods, and I think I can be very short about that. Yeah? So you can really extract large amounts, huge amounts of knowledge, entities, relations for populating ontologies, and knowledge of more complex kinds from natural language texts and other sources. And this is complemented during the last years by these social effort of Wikipedia, for example, where people provide lots of knowledge in natural language form in a controlled way. And so you can get at very, very good and nice and important results. But this everything is offline so far. And it lives on the fact that you have this huge redundancy in the world of all kinds of information that are around. But what happens if you want to look into the living cell? So what happens if you want to find out about the meaning of a sentence that has a complex structure, that has words that come with meanings, and that is uttered in a context that is again of some complexity? So one example is you want to ask a complex question during an information-seeking dialogue. Another possibility is you want to find out about the precise semantic information of a sentence in not in a novel, but in a newspaper article, or you want to translate a complex sentence from one document to the other. So in this case, you have a different task. You have really to go into the detail of the processing, and what do you find there? So I think the syntax has made an amazing progress during the last decades and has become very, very good. But if you want to find out about the meaning, if you go into special applications, we have seen very nice and impressive example this morning by the two keynote speeches about dialogue and machine translation. You also see very nice, let me say, local solutions. But if you look at a general solution, general treatment of this problem, then you somehow face this statistical or probability cloud so far. So my vision is not to wait for somebody who invents the microscope, but to take the methods and tools and resources that are around. I mentioned already the almost perfect basis that syntax provides us with. So that's one thing. Another thing is one can go, for example, let me say that as a semanticist, into distributional semantics and try to bring more structure into distributional semantics, for example, to make it compositional. Yet another method is to somehow take syntax, take kind of a logical representation formalism, but downscale it to the way that you can treat it and combine it with some kind of statistical knowledge. So that's something that, for example, a very nice example of this kind of work is Bill McCartney's dissertation, where he modeled a compositional concept of inference. And yet another approach to look at, I think, is to take all this information, this knowledge, well-structured knowledge that is around and in part has been gained by it's extracting information from linguistic texts and use it, put it again into the task of the local interpretation, online interpretation of linguistic utterance. So my vision is, it's a very conservative one. I think that was the more or less the oldest vision in computational linguistics. I don't know whether Martin would say something different, but to my knowledge, it's natural language understanding. And I think we are in a position now that we can take up the challenge of natural language understanding again. So my vision for the next decade is will be hopefully a decade for natural language understanding. And I like, and of course, there will be a lot of applications that will be facilitated by improving on this fine-grained natural language understanding. I like applications, but I love foundational research, as some people know. So my idea is that by proceeding this way, we can also find out or make some progress in understanding natural language, understanding the process of natural language by doing so. Maybe I'm much too optimistic. I heard that Martin said something about the computational linguistics of the 20th century yesterday, which I missed, and maybe in the light of what he said, things don't sound that promising. I don't know, but I'm optimistic optimistic, I would propose to take up this challenge again and look into the real task of natural language understanding with everything we have gotten in between. Thank you.
Thank you. Thank you, Manfred Pinkal, for the statement. So try it again, natural language processing, natural language understanding, really understanding, and maybe we go into the final discussion. Is that okay? All right, so then if there is an urgent question, please stand up. But I guess, Hans, do you want to use slides or something? Do you have to prepare anything? Okay.
Because then I would try to.
All right. So then, thank you very much, Manfred Pinkal, for your statement, and.